are going to complete our examples of dynamics revisions, rectilinear motion. We have an example here. A particle moves in a straight line with initial velocity 3 meters per second from a constant point such that acceleration equals 6x plus 4 meters per second squared. Find v squared in terms of x, and then find the velocity when x equals 2 and x when v squared equals 87. Okay. Here we have acceleration as a function of x, 6x plus 4, okay, and acceleration of variable depending on x. Then we have integral a dx equals v dv. Okay, here we have this integral of a 6x plus 4 dx as acceleration as a function of x equals integral of v dv. Then we have here 3x squared plus 4x equals v squared over 2 plus constant. To find this constant at x equals 0, okay, v equals v naught equals 3 meter per second. At x equals 0, v equals 3 meter per second. Then by substitution here, c equals negative 9 over 2. Okay, then we have here 3x squared plus 4x equals v squared over 2 minus 9 over 2. From here we can find v2 equals 6x squared plus 8x plus 9, and this is required number 1. Okay, then it's required to find the velocity when x equals 0. Okay, now v at x equals 0, v square at x equals 0, here you have 9. Then v equals here at x equals 2, here when x equals 2, then we have to at x equals 0, okay, you can continue like this. At x equals 0, v equals positive or negative 3, okay, 3 meter per second. At x equal 2, then v squared x equal 2 equals here 6. Here we have 24 plus here 16 plus 9 equals 49. Then v equals positive negative 7 meter per second. Okay, finally it's required to find x when v square equal 87. At v square equals 87, we can substitute here. We have v square equals 6x squared plus 8x plus 9. This value equals 87 equals 6x squared plus 8x plus 9. Then we have 6x squared plus 8x minus 78 equals 0. Then here by factorization we can find x equals 3 meter or x equals negative 3 over 3 meter, and this is required to find. Another example, a particle moves in a straight line such that its displacement is equals t power 3 minus 60 squared plus 90 meter t in second. Find the acceleration of the motion when a velocity equals 0, and then find velocity when acceleration vanishes. When motion is accelerating, decelerating, find the distance covered during the first 5 seconds. Okay, for number 1, here we have s equals t power 3 minus 6t squared plus 9t. By differentiation, we have v equals 3t squared minus 12t plus 9. Differentiating once more, then we have a acceleration equals 6t minus 12. Okay, it's required to find acceleration when velocity is vanished. Then we have v equals 0. Then we have this 3t power 2 minus 12t plus 9 equals 0. Then we have t here equals 1 or t equals 3. Then we have two values of a at t equals 1. By substitution here, 6 minus 12, we have negative 6 meter per second square. Okay, and we have another a at t equals 3 seconds. this is equals 6 meter per second square. Also, it's required to find with number 2 the velocity when acceleration vanishes. Acceleration vanishes, a equals 0. Then we have 6t minus 12 equals 0. Then t equals 2 seconds. Substituting here, v equals 3, 2 squared minus 12 times 2 plus 9. Then we have here negative 3 meter per second. This is required second. Okay. For number 3, we need to find when the motion is accelerating and decelerating. Then to identify the motion accelerating and decelerating, we have to check VA. If VA is greater than 0, then the motion is accelerating. Is VA less than 0 or negative value, then the motion is decelerating. Okay, or we can find it from the graph. Okay, here we have V equals 3t squared minus 12t plus 9. We can sketch this roughly like this. Okay, this curve representing V with respect to time. Okay, this is like this. We have here to check the accelerating or decelerating condition or status of the motion before and after or each change of velocity, or when v before and after v equals 0. We have here v equals 0 at t equals 1 and t equals 3. Then we have here 3 time intervals. You have to study the motion within these intervals. Okay, we have this one, we have also this one, and we have this one. Okay, as it's required to find but if we check this second interval, we can divide it also into 2 sub-interval here as the slope of the tangent to the curve during this interval and this interval changes. Then we have also to check the acceleration or deceleration during this one. Then we have here four time interval to check the condition of or status of this motion within. Okay, we have first from 0 okay to 1 second. Okay, here we have this time interval, and from 1 to 2, and from 2 to 3 seconds, and then from 3 okay, 3 to whatever. Okay, or when time is greater than 3. Okay, then for first interval from 0 to 1, okay, we have to find first the sign of the velocity. Here the curve is above x-axis as we are dealing with vt curve. Then the velocity is positive here. Okay, then the direction is forward. Okay, for acceleration here in this type of curves is the slope of the tangent to the curve within this time interval. Here the slope is negative as the angle made by this tangent with a horizontal axis is obtuse. Then we have here acceleration is negative, here negative. Then VA is less than 0. Then motion here is decelerating. Okay, during this first interval. For second interval from 1 to 2, okay, V equals V is negative value as the curve of the velocity function is below this horizontal line or axis. Then V is negative during 1 to 2 second. Okay, then we have to find the sign of A. Still we have the tangent of this curve during this time interval, making an obtuse angle with the horizontal line. Then the acceleration is negative also. Then we have acceleration is also negative. Then VA equals positive value. VA equals a positive value as we multiply negative value is a negative value, then v is positive value greater than 0. Then here the motion is accelerating, okay, but in backward direction as v is negative, okay. For the time interval 2 and 3, okay, we have velocity is negative as well. The motion is in backward or reverse direction as v is below this horizontal line, then v is negative. Acceleration here is positive as the slope of the tangent the tangent of this curve during the time interval 2 seconds to 3 seconds is positive as the angle made by this tangent to the horizontal is acute. In here acceleration also is positive. Then we have VA is negative, less than 0. Then the motion from 2 seconds to 3 seconds is decelerating, okay, in backward direction as v is negative, okay. And finally when t is greater than 3, okay, 3, then we have velocity is positive again, okay, the direction changed again. Then we have v positive as the curve is above x-axis, okay. Acceleration here is positive as well as the slope of the tangent to this curve during t greater than 3 is positive as the angle made by this tangent with the horizontal is acute. Then we have slope and the acceleration is positive. Then we have VA is positive as well, and consequently the motion when t is greater than 3 seconds is accelerating in forward direction, and this is required to find. For item number 4, it's required to find the distance covered by this body during first 5 seconds, okay. We need to find distance. Distance means we have to use positive displacement or distance covered. Then we are going to use this modulus, okay. Then distance x equals integral from 0 to 5 modulus of v dt, or equals modulus from 0 to 5 v dt, okay. Then we have also first we have to find when v equals 0 or the direction of motion changes, okay. As we explained before, v equals 0 at 1 second and t equals 3 seconds, 30 seconds, okay. Then we have here two sub interval. We need to find the distance from t equals 0 to t equals 5. Then we have two conditions here. We will use modulus, okay, to find the positive distance or displacement only, okay. Secondly, we need to find when the v equals 0 or vanishes, or the direction of motion of this body changes. Here we have two times, two instant at t equals 1 second and t2 equals 3 seconds. The direction it changes, the velocity sign changes, okay. Then we have here three intervals, okay, or sub interval from 0 to 1, from 1 to 3, from 3 to 5, and we have to calculate the modulus of the distance or the displacement covered by this body during each of these interval, and sum all these distances. Then we have x equals modulus from 0 to 1 v dt, okay, v dt, plus we have here from 1 to 3 integral of we have modulus, okay, integral of 1 to 3 v dt, and plus integral from 3 to 5 v dt as well, okay. Then we have here integral from 0 to 1. We have v 3 2 square minus 12t plus 9, okay, dt, okay. This is plus here modulus from 1 to 3 3t square minus 12t plus 9, okay, dt, okay, plus here also from 3 to 5 3t square minus 12t plus 9 dt. Now by executing all this integration, okay, and then substituting by this upper and lower terms in each definite integration, then we have, for example, here we have t power 3 k minus 6t squared k plus 9t, okay, and we have to substitute by 1 and 0. Then we'll repeat here, okay, we'll use this t power 3 minus 6t squared plus 9t. This is integration of this velocity, okay, and we'll substitute by 1 and 3 and 1 plus modulus, of course, of t power 3 minus 6t squared plus 9t from 3 to 5, okay. By substitution, we'll find here x equals the magnitude of this quantity equals the modulus of this quantity equals 4, and this one is 4 as well, and this one is 20. All these distance are positive, okay. Then we have here the total distance covered by this body during the first 5 seconds equals 28 meter, and this is required to find. Now we may say that if it's required to find the displacement covered by this body, okay, during first 5 seconds from 0 to 5, okay, as we said before, we have to use the integral s equals the integral v dt from 0 to 5, okay, from 0 to 5 regardless. We will not use the modulus here. We will not use the modulus here. Then we are regardless when v equals 0 or the direction of motion changes. Then here, as we are dealing with displacement, this is a vector. Okay. Then we have here v integral from 5 to 0 to 5 v here is 3 to square minus 12 to t plus 9, okay, dt. Then we have here t power 3 minus 6t square plus 9, okay, from 0 to 5. This is equals 20 meter, okay. This is the total displacement covered by the body within the first 5 seconds, okay. And it's clear also that as we said before, the distance covered, okay, is greater than the displacement covered by the body within the same time interval. As here we are not considering the direction of motion, but here we are considering this direction of motion. Then of course this distance covered by the body in all direction, positive direction and negative direction, will be more than this displacement, as we have positive direction, and if we have a negative direction, as in our case, we'll subtract this displacement from positive displacement. Then finally, and usually this distance is greater than displacement covered by any body within the same time interval. Another example, a particle moves in a straight line from a constant point from rest, such that acceleration a equals 3 over 8 x squared meter per second squared. Find the velocity at x equal to meter and find the position at v equals 4 meter per second. Then we have here a is a function of x, a equals 3 over 8 x squared, okay. Then we have a relation between v and a. Integration of a dx equals integral of v dt, okay. Then we have integral of 3 over 8 x squared dx equals integral v dt. Then integral v dt equals here 3 over 8 is a constant. Then we have x power 3 over 3, okay, plus c. Here we have v, okay, equals here 1 over 8 x power 3 plus c. To find this c at x equals 0. Okay, here the motion started from rest, then v equals 0 at then, and c consequently a equals 0. Then we have v equals 1 over 8 x power 3, okay, plus 0. Then v equals 1 over 8 x power 3. Okay, it's required to find this value at x equals 2, then v equals 1 over 8, 2 or 3, then v. Another example, a particle moves in a straight line from a fixed point from rest such that acceleration equals 3 over 8 times x squared meter per second squared. Find v at x equal to meter, position at v equals 4 meter per second. Okay, here we have acceleration of as a function of x, then a equals 3 over 8 x squared. To find v, we have a relation here, a dx equals integral a dx equals integral v dt. Okay, then integral 3 over 8 x power 2 dx equals integral of v dt. Then we have here v dt, integral of v dt equals 3 over 8 integral x squared dx, then have v squared, okay, equal 3 over 8 times x power 3 over 3 plus constant. Then we have here v square, half v squared equals 1 over 8 x power 3 plus constant. To find this constant, it said that at x equals 0, the motion started from a fixed point. At x equals 0, v equals 0 as the motion started from rest. Okay, then we have here c equals 0 as well. Then we have v2 equals 1 over 4 x power 3. At x equals 2 meter, then we have v square equal 1 over 4. Here we have 8, this is equal to, then v equals plus negative root 2 meter per second. This is first. Okay, it's required to find position at v equals 4 meter per second, as we have v squared equals x power 3 over 4. Okay, then x power 3 equals 4v squared. Okay, then x equals root to the order 3. Okay, v 4v squared. Okay, this is equals 4 times here we have v equals 4, then we have 16 here. This is equal 4 meter. Okay, then x equals 4 meter at v equals 4 meter per second. Okay, and this is required. We have an example. If a equals 3, v node equals negative 1, then find the distance covered during time interval 0 and 2. A acceleration, v velocity, t time. Then we have a is a fixed value, the constant. Okay, a equals 3, and we have v equal integral of a dt. Okay, then v equals integral of 3 dt. Okay, this is equals then v equals 3t plus constant. Okay, to find this constant, it's given that at t equals 0, we have v equals v node equals negative 1. Then here v equals negative 1. Then v then constant equals constant equals negative 1. Okay, then here we have v equals 3t minus 1. Okay, this is the equation of the velocity. Okay, it's required to find the distance. Okay, we need to find distance, then we have to use modulus, okay, of the displacement or distance covered. Okay, and we have to check v equal 0 at which time. Okay, here v equals 0 where 3t minus 1 equals 0, then we have t equals 1 over 3. Okay, at this time v equals 0 or the direction of motion of this body changes, then we have to divide the time interval. If t is included in this time interval, we have to divide this whole time interval into two time intervals. Here we have here from 0 to 2 seconds, and t1 over 3 is included in this time interval. Here, for example, 1 over 3 seconds. Then we have two intervals here, this one and this one. The direction changed at 1 over 3 at v equals 0. Then we have distance x equals modulus integral from 0 to 1 over 3 of v dt plus modulus of integral from 1 over 3 to 2 v dt as well. Then we have here modulus of integral of 0 of 1 over 3. We have v 3t minus 1 dt plus from 1 over 3 to 2. Here we have 3t minus 1 dt. Then we have here 3 over 2 t square minus t. Here from 0 to 1 over 3 second, plus here we have also 3 over 2 t squared minus t, from 1 over 3 to 2 second. Here we have to substitute by 1 over 3 minus 0. Then here 3 over 2 modulus. Here we have 1 over 3 squared minus 1 over 3. Minus here when t 0 minus 0, then here minus 0. Plus in this bracket we have here 3 over 2 squared minus 2. This is 1 minus when we substitute by 1 over 3, we have 3 over 2, 1 over 3 squared minus 1 over 3. This is second 1. And we have to use modulus like this. By calculation we'll find that the magnitude of this one is 3 over 1 over 1/8, the modulus of this bracket, and we have here plus 72 over 1/8. Then the distance covered during the time interval 0 and 2 equals 78 over 1/8, and this equals 30 over 3 unit, length unit or distance unit, and this is required to find.